This section is over solving quadratic equations by finding the square roots. Before we go into solving equations, we're first going to have a brief summary of what a radical is, or what a radicand is. Anything with a square root sign, such as this one here, is a radical, so you won't hear square root all the time. If I tell you to simplify the radical, this is just another way of telling you take the square root of a certain number and simplify it. There's a few properties that you should write down in your notes. One of them is the product property. This right here is telling you that if you have a number underneath the square root, it can be split up into two square roots or two radicals being multiplied by each other. So for instance, if we had the square root of 20, we could break that up into the square root of 2 and the square root of 10 multiplied together. And when you use this rule, it's just going to help you figure out how to simplify it even more. You also have a quotient property that if you had a fraction underneath the square root or the radical, you could also break this apart as well and be the square root of the top number divided by the square root of the bottom number. So if we had the square root of, let's say 40 divided by 2, you could break that up and say the square root of 40 divided by the square root of 2. And then you could go and simplify it from there. So these two properties that I just showed you will help you simplify radicals. And we're going to do some practice problems. So here we have the square root of 24, and they want us to simplify it. Now, not all of us are going to choose the same radicals or the same factors of 24. But you want to try to use, if you go through and you list out the factors, you want to try to use one that has a perfect square. And I can tell you right now, I know that 4 has a perfect square. So I'm going to use 4 and 6. Okay, so that would be your first step, just applying that property that I showed you in the previous slide. Now you want to take each individual radical and simplify it if you can. What is the square root of 4? It's not square root of 2 times square root of 2, it's just 2. And the square root of 6, if we were to break that down, could we find two factors of 6 that will have a perfect square? No. 1 and 6 do not have a perfect square, and neither does 2 or 3. So we're going to leave the square root of 6 alone. And this is our answer. 2 square root of 6 is the same as square root of 24. Let's try another one. We have 90. Again, we're going to break this apart into two different factors. And before you choose which ones, if it helps you, write them down. I know it helps me. 2 goes into 90. 45 times. 3 and 30. 4. No. 5. 5 goes into 90. 18 times. We have 7, 8, 9, and 10. Okay, now you go through your list. And of course, when you come up with these factors, you can use your calculator. Just do 90 divided by 1, 90 divided by 2, 90 divided by 3, and just keep going until you get to two factors that are very close and you can't go any further. So, does 1 or 90 have a perfect square root? No. 2 and 45. 3 and 30? No. 5 and 18. Does 9 and 10? 10 doesn't. but the 9 does. So I'm going to use 9 and 10. So now I look at the square root of 9. Does it have a perfect square? Yes, it does. That's why I chose it. 3. And now you do the square root of 10. Factors of 10 are 1 and 10, 2 and 5. Do any of those have a perfect square? 1 and 10 do not. 2 or 5 does not. So square root of 10 does not go any farther. This is your simplified answer. Now let's try one with a division sign. The first step you want to do is make sure that you can't divide it in how it is already. Can 7 be divided by 16? No, it cannot. So just break it apart like the rule that I showed you says to do. Now, the square root of 7. Does that have a perfect square? The only factors of 7 are 1 and 7, so no. That is going to stay just like it is on top. Is there a square root of 16? Yes, there is. 4 times 4. So 4 is the answer. So this square root of 7 over 4 is the simplified radical of the original one they gave us. Here's another one. Square root of 7 over 2. Can you divide this and get a whole number? No, you cannot. So you're going to split it apart and go from there. Can you take the square root of 7? Yes, you can. You can get a long decimal number, but we want it simplified, and long decimal numbers are not simple. So the factors of 7 are 1 and 7, and you know from the previous problem that no, that does not work. So the square root of 7 remains on top. Can you take the square root of 2? Well, the factors of 2 are 1 and 2, and neither one of those can be squared or square rooted. So the square root of 2 is also simplified. So you could either write this as your answer, or you could just circle this and say it's already simplified. All right, now that we know how to simplify radicals, we're going to use all of that knowledge and solve it in a quadratic equation. So when you solve an equation, I want your answers to be in simplified radical form. And your book will also ask that as well. So here we have a quadratic equation. In order to solve this, we want to isolate everything away from x squared. So we're going to get rid of the 1 by subtracting it on both sides. So you have 2x squared equals 16. Now you're trying to isolate everything away from x squared. Well, you have a 2 in front and it's being multiplied, so we have to get rid of it by dividing it by 2. So now we have x squared equals 16 divided by 2, which is 8. Okay, now the last step you have to do is get rid of the square, because we want x to be by itself. How do you get rid of something that is squared? You square root it. So I'm going to rewrite this over here so I have some room. Square root both sides, and that cancels out that squared, so you're left with x. Now, the only thing I need you to remember, and you might have forgotten this from Algebra 1, but whenever you're solving, you have an equal sign, and you have a square root, remember that if I gave you the square root of 4, you could say that's 2 and negative 2, because negative 2 times negative 2 equals positive 4, and 2 times 2 equals 4. So both of these answers were right, and the way that we write that is a plus minus 2. And that's only used when you are solving. So since there's an equation and we're asked to solve a quadratic equation, you want to make sure you write the plus or minus in there. You will be counted down if you do not write that. All right, now we could just write the square root of 8, but you have to make sure the square root of 8 is simplified. So we're going to look at the factors of 8, which is 1 and 8, 2 and 4. And we want to know, are any of these perfect squares? And I know that this one is. So I'm going to break apart, we're going to rewrite this. I'm going to break apart the 8 into 2 times 4. And now I'm going to simplify just like I showed you in the previous slides. We know the square root of 2 cannot go any farther, but we know that the square root of 4 can. You always put your whole numbers before the radical. So the square root of 4 is 2, and the square root of 2 cannot go farther, so we'll put that right afterwards. And there's the answer. There are 2 answers to this equation. Positive 2 square root of 2 and negative 2 square root of 2. And of course, if I asked you what the exact value of this, you could punch this in a calculator and put plus or minus the big long decimal number. But for now, you're just going to leave it as simplified radicals. All right, here is one more, and I think this is the last slide. Instead of having just x squared by itself, we have x plus 5 in parentheses. So we want to isolate everything away from x first. And I'm going to start with the 1/3. In order to get rid of 1/3, we multiply by its reciprocal on both sides. That way the 3's cancel, the 1's cancel, and we're left with this. Seven times 3 is 21, and divided by 1 is still 21. So I don't have to write the 1. Now we need to get rid of the squared, because you cannot just minus 5, because that's inside the parenthesis. That's part of the squared. And you don't want to take the x plus 5 and multiply it by another x plus 5, because then you'll just have a ton of stuff going on. It is way easier just to get rid of the squared right away. So let's square root both sides. That way it cancels out and you're left with x plus 5. And now that parenthesis can go away because it's no longer being squared. And now we need to get rid of the 5. So we subtract the 5 on both sides. Notice how I did not say 21 minus 5 and give just a number underneath the radical. You cannot take radicals and whole numbers and subtract them. They're not like terms. So we have x equals square root of 21 minus 5. And we want to put our plus or minus in there. And the last thing you want to do is make sure your radical is simplified. So the square root of 21, we have 7 and 3, and of course 1 and 21. And you look at either one of these, neither pair is a perfect square, so the square root of 21 is done. Now you can write your answer just like that, or another way to write it is to put the negative 5 first, which is what you have here, plus the square root of 21.